Slide number 53. There are only three types of clutches used in order to tap the positive power. They are the inertia type clutch, the friction type clutch, and the ratchet type clutch. There's only one inertia type clutch, and it is mounted directly on the motor shaft. All of the friction type clutches utilize springs to make the mechanical connection between the operational shaft and the driven mechanism. The ratchet clutches also use springs to engage their pawls with the ratchets. With the exception of only one of these friction clutches which use springs, all we need to do in order to cause a clutch engagement is to release the springs, because at rest, or when not in use, they're kept distended or opened. When these springs collapse, they lock the operational shaft to the driven mechanisms. We will refer to these clutches as collapsing spring clutches. In the case of just one clutch, namely the carrier return clutch, we must cause the spring to collapse in order to make the mechanical connection between the driving operational shaft and the driven parts of the machine. As a result, we call it a collapsible spring clutch. Below the red line, we have named the clutches by the mechanisms which they drive. The carrier return mechanism, for instance, is the only mechanism which uses the collapsible spring type of clutch. We shall now study these clutches separately and explain the manner in which they operate. Let us start with the motor clutch. Slide number 54. As we turn the motor on and off, we observe that the motor pulley can turn or idle freely on the motor shaft. The reverse is also true. When the motor is turned on, we can see that it is possible to rotate the motor shaft without driving the motor pulley, because the motor shaft and the pulley are not locked onto each other. This motor clutch has been incorporated into the machine in order to allow the motor to approach normal operating speed before it engages with the motor pulley. This way, the motor has a chance to first develop enough torque so as to be able to drive the heavier mechanisms of the typewriter. Slide number 55. Right next to the motor pulley, we find the clutch hub plate, which holds two clutch pawls. The pencil is pointing at the pivot point of one of these pawls. Notice that this plate is solidly mounted on the motor shaft by the use of set screws. Slide number 56. At the end opposite to that of the mounting stud, we find this metallic mass permanently mounted onto the pawl. At the tip of the pawl, below the pencil, we find a spring which tends to pivot the pawl clockwise in such a manner that the indicated mass is constantly pulled towards the center of the shaft. In order to understand how the motor clutch operates, we should remind ourselves that once a body is in motion, it tends to continue its motion in a straight line, unless it is acted upon by some external force. At the exact point in time when the motor is turned on, the torque of this shaded pole motor is zero. We will study more about the motor a bit later. It takes quite a bit of time for this kind of motor to reach its operating speed. It is very important that during this time the motor be completely free to rotate without having to carry out any typewriter function. The motor might stall and actually burn out if it were to get a heavy load during this time period. However, once the motor approaches its operating speed, these masses on the pawls try to continue their motion in a straight line, seemingly away from the center of the shaft, against the action of the spring fastened next to the pawl mass or weight. Slide number 57. Once this happens, the heels of the pawls rotate towards the center into the way of one of the teeth of the motor pulley, as indicated. While there are 3 teeth on the motor pulley, they are positioned so that only one of these clutch pawls engages with the motor pulley at any one time. Examine this as best you can before continuing with the program. Slide number 58. Next, we will remove the motor from the typewriter. First, unplug the machine. Under no circumstance should you continue without unplugging the machine. Most of the procedures proposed in this training program represent but one way of doing things. You might find or develop some other way of accomplishing the same job and feel more comfortable about it, be it because it seems to be a shorter way or simply because you like it better. Consider yourself encouraged to follow your own inclinations whenever they lead you to the desired results on the typewriter. The only restraint is that in disassembling any mechanism, you should never attempt on your own to go beyond the limits of your ability to properly reassemble the mechanism which you decide to take apart. At times you may find that your machine has parts which are slightly different from those being shown on the slides. When the difference is minor, we may not even mention it on the tape. It is then left up to you to analyze the variation in construction of such a mechanism, and you will actually have to rely on your own ability to analyze and trace mechanisms. Our first step in the removal of the motor is that of removing the belt from the motor pulley. Notice, however, that we will have to move the belt over the washer and the clamp located at the end of the motor shaft, and that this is not so easy because of the fact that the belt does not have sufficient slack in order to allow us to do that. We could, of course, remove the clamp and the washer at the end of the motor shaft. A reasonable alternative to this is that of first creating the slack needed for the belt removal. Slide number 59. With the aid of a screwdriver, we can easily slide the belt towards the left and push it into the space between the hub pulley assembly and the bracket located to the left of the hub pulley. Slide number 60. Why don't you do this on your own machine now, until you get your motor belt into the position shown here? Stop your tape player to give yourself time. Slide number 61. As you can see, once the belt is off the hub pulley assembly, it is very easy to lift it over the washer and the seat clamp at the end of the motor shaft. Go ahead and do the same on your own machine. Slide number 62. The motor mounting brackets vary. Some motors are mounted into a solid bracket, such that at least one of these brackets has to be removed from the machine in order to allow the removal of the motor. As is evident in this picture, this bracket will have to be loosened anyway in order to release the power cord. Slide number 63. Notice the 2 indicated clamps. They can be taken off the motor mounting brackets. When we remove the clamps only, leaving the position of the brackets undisturbed, we can reinstall the motor knowing that the tension of the belt remained unchanged after we reinstalled the motor. It is important to always restore sufficient belt tension so as not to allow the belt to jump any cogs or teeth, even when it has to operate the typewriter under maximum load conditions. Whenever we reinstall a motor, we must try to position the motor so as to give us maximum belt tension and minimum idling noise. In addition to this, the angular position of the motor must be such that the belt tracks in the center of both the motor pulley and the hub pulley. At this point, you have reached the end of the audio tape 1 for this segment. You may continue your studies by using tape 2 for the segment number 10-1A.